I'm Taylor from Volk Cooperative and also CNF Testbed, here with Nikolai. So we were going to talk about a hybrid use case. That talk is going to be deferred to maybe ONS or a later KubeCon, and we'll get back to that. So we're going to be talking about a different use case using NSM and the CNF Testbed. Here's what we're going to go through. Talk a little bit about CNF Testbed itself, the different components and its purpose, and then the use case, and maybe a little Q&A. So Michael Pedersen from Intel wasn't able to make it, but did want to do a call out to him, because he's done a lot of work on this use case and a lot of other ones. We have a lot of contributors in the CNF Testbed from different projects, FDIO, CSIT, lab. There's a lot of cross work between those. Of course, NSM and several other projects. So here's some of the companies that have been contributing to both test cases and tooling and other things. So the CNF Testbed, for those that you don't know, this is a CNCF initiative, and we're working with the Telecom User Group. The idea is to provide an area to test out and try out all these different examples that we've been talking about all day, and both NSM and other pieces, different testing and software, and trying out the different ideas to see when we have specifications, what do we actually get? And it's all open source. They're at this GitHub on CNCF.org, and the main target for us has been Packet. The tooling we do have broken up to where you could ideally use it other places, but if you have a Packet API key, then you should be able to provision Packet machines, provision the network, provision the workload on top of that, everything else. And if you would like to contribute to other places, like we've had some work to make it actually function a lot of the tests on the LF CSIT labs, and we'd love to add others. So a little bit about the pieces here. So it's hardware provisioning, workload provisioning, and those are really what we're saying is the infra from the physical side, and then what is the base platform before you put whatever applications, network functions, whatever you want on there. So we blend in stuff like Multis and NSM and anything else that would be add-ons to extend, say, Kubernetes, or a vSwitch that you may swap into OpenStack. That's all the workload infra is how we look at that. And then the different use cases and examples. Some of them aren't full use cases. Some of them are saying, here's a small bit of software like maybe a device plugin. And working with some folks on network functions of different types, examples. And we use tooling from different places. A lot of it's upstream, like OP and FE stuff, like the CNF bench for benchmark testing when we're doing that type of testing. Sometimes it's functional. This is just a quick view of a lot of the different software pieces that you could see deployed. This is one example, because it depends on what we're actually going to be running. We do support provisioning OpenStack as well as Kubernetes. And right now I'm primarily talking about Kubernetes here. So the underlying infrastructure, and this is, by the way, something that we've been progressing to as a split. We've been deploying up until this point as one batch. So when you're building it out, it would actually provision the machines and then immediately bootstrap Kubernetes, set everything up in one go. We've splitting that out. So this will be coming in and replacing what's there over the next couple of weeks. It's being used on some other projects. But mainly it's Terraform and Ansible. So we've used Terraform to provision. You can use it for provisioning anything, AWS, IBM, cloud. We use it for provisioning machines on packet. And then we have some Ansible and some other custom code to talk to the packet API for pieces that Terraform and other bits of code that may be available from packet aren't available, but they're in the API. So stuff like turning the network from their normal layer 3 into either layer 2 or a hybrid. So you can get access to the ports and add VLANs on the rack and assign them to different ports. And then the Kubernetes workload infra, which would be similar for the OpenStack side. We are using KubeSpray for the bootstrapping. We actually wrap that a little bit because we do some extra stuff and give it a declarative, simple way of saying what the cluster is. We can pull those, the machine information or nodes that you want from different places, including you could specify them. So you could target something that wasn't on packet and provision this way. And then we have, again, code that's custom for either host level or out of band with either Kubernetes or OpenStack, where maybe something isn't integrated and you need to, maybe you want acceleration that's you wouldn't have access to. And a lot of the other pieces, like NSM, we can deploy with Helm. Other stuff, we may just be kubectl. But that's kind of what that is, and we've tried to break this up into blocks. So the other part would be the use cases themselves. And this is kind of going through a refactor from where we were. I'm going to bring this up really quick. So we have this kind of split. We have a whole other section with a lot of our original tests that were focused on benchmarking, and we've moved a lot of it over. But the main idea here is you have workload infra type of components, and that can be stuff like adding Multis or the SRV device plugin from Intel, NSM, and other parts that we're going to be adding, hopefully adding Tungsten Fabric, Dan-M in the queue as well. And then you have what may be the wrong name, but use case section. What this is sometimes it's a use case, sometimes it's simpler examples, and this is kind of the overall structure. And ideally with the new setup, specifically for Kubernetes, these are in composable pieces where you can add more and more parts to build a larger use case. The tooling is all either upstream and we push stuff back, or the pieces here are all open source and wrap that. I mentioned Terraform. There's some stuff for wrapping the packet API, and then all of the Ansible playbooks and everything are available. Let me see. A couple of specific use cases, and then maybe we'll switch on. Where are we on time? We good? All right. So this would be an example. This particular example we'll be talking about on Thursday for the intro deep dive, and this goes into one that we've been using for benchmarking that's now rewritten and deploys with Helm, and some other pieces. This actually uses a vSwitch, and some of those parts might actually be interesting with like the Tungsten Fabric and the vRouter and stuff there. And then we have examples like this device, Intel device plugin. And with this one, we actually have a companion example that's for the workload infra. And this installs the parts needed on the Kubernetes so that can be used. And then we have a use case that's being built out that uses this plus Multis plus other parts. And the idea here is with one of the main intents is if someone's coming in either thinking infra or maybe you're developing network functions and you're trying to piece something together and maybe you understand one part, how do you do that? And this is a little bit different from, say, a whole reference platform where something's decided. So the idea here is you want to look at a piece of software and try it out. So how do we do that? And then how do we share it? Because you may have access to your own lab, but this is built to run on a public lab. Maybe it's a starting point for what you want to do. And I think that's probably a good intro. And I'm going to hand it over to Nikolai, and we're going to dig into specifically this multi-gateway packet filter use case, which is one of the more complex ones that we've been building with network service mesh. Yeah. Present again?
Okay. Okay, let me step a little bit back before I go deep into the use case. For the most of you that were here in the morning, I would compare the CNF Testbed as to the Meshery project. So essentially, this kind of shows the dual nature of NSM. So NSM can be a solution for enterprise. This is what we are testing with Meshery. Okay, not we, but the Meshery folks are kind of exemplifying testing, putting in their environment. With the CNF, this is mostly about more hardcore networking, telco style of networking, if you will. For us as a community, both projects are giving a lot of value. I spent a lot of time with Michael on bringing NSM to the CNF testbed, and because this has been recorded, Michael, thank you. Hope to see you in Amsterdam. No excuses. As a result of this common work, this universal CNF that has been shown here on several other presentations was born. It was a good cooperation and good feedback between us and the CNF testbed initiative. Actually, at Antwerpen at Open Networking Summit was the first complex network service mesh deployment that I have ever saw. It was with 5 parallel services running together. It's a really at least for me, was very impressive to see how these things worked together, were pieced together and demonstrated. Now, getting to the specific example. So this was developed specifically for KubeCon North America, and there's going to be a deeper dive in it later this week. Is it on Thursday? Thursday. So for those that are interested, there's going to be a special session. Please come and check it out. Here's the link. We're going to upload the slides on the site for NSMCon. You're going to see to be able to follow the link and check out how exactly this is implemented. It's based on essentially on the CNF framework with Ansible Helm installs, the charts that we have provided from the upstream. I don't know where we are announcing the release at, but essentially we have an upgraded way for deploying NSM now, so probably there's going to be some updates in the following weeks. We're going to work together, both communities. What the example looks like, I will skip to this slide just for visual representation. Essentially, there's a single packet filter. This is sitting in the center here. It is based on the examples universal CNF, which is based again on the Ligato's VPP agent and incorporates VPP as a core data kind of packet processing engine. So this packet filter is essentially forwarding and limiting the access from different clients to the various gateways. As you can see on the left, there are two types of clients. One is the so-called kernel client, the other one is a VPP client. The purpose here is to be able to demonstrate how various data paths work. So as you can see with the kernel client, we have the NSM forwarder sitting in the middle. It is essentially terminating two sets of VATH pairs so that you can get connectivity between the kernel client and the packet filter. And the other one is the VPP client essentially is talking through MEMIF, which is a shared memory interface, because all this setup is on one Kubernetes and one worker node. Essentially, it's a direct shared memory between the VPP client and packet filter. On the other end, the external gateways, this is a concept that we are trying to develop and to probably make it upstream. For the time being, we're experimenting with it. I'm talking about the gateway concept. This is essentially a way to get packets in and out of the NSM. So a lot of the examples that we have seen today, they're mostly talking about how you connect clients and endpoints within NSM, how you connect Istio-enabled, Istio proxies, envoys enabled with NSM, how they talk to each other through inter-domain connectivity, etc. But specifically with the CNF, this is again one of the lessons that we learned and some kind of a real-world feedback that we are learning from is how do you inject traffic, for example, or how you send the traffic out of NSM. So that's how this gateway concept is kind of implemented. We have been talking about this for a long time within the community. There has been some documents, some specs going around. We didn't settle on anything, so for the time being, we're implementing it here. These are privileged VPP containers. They have direct device assignment of PCI devices that are on the host, 10 gig NICs, if I'm not wrong.
The 10 gig NIC that's a limit of packet. All of their networks
Yeah.
10 gigs.
Yeah, it's just something that DPDK can talk to, not specify that it should be a 10 gig NIC. The thing is that on the left side here, you have essentially MEMIF, which is managed through NSM. On the right side, you have essentially a PCI device attached, which goes out and goes directly to the external system.
They happen to have VLANs, and so some of the previous examples that we're not showing right now, we actually sent the traffic based on some of that and a larger network. But I think the other part to point out would be, so the gateway is partly an exit point for NSM. It's also building on other benchmarking examples where we were doing direct access to the NIC, and we have a couple of different paths for doing non-privileged. There is some issues with VPP, and there's like an open issue in the CNF testbed that's linked to some Jira where they're trying to resolve those, and I think we'll be able to run as it is, unprivileged, and then the other path is going to be using different CNI plugins. Ideally, once we have the Multis and Intel device plugin, that'll be one example, and we'll be able to put it in here. But it's different ways of accessing it and then providing the exit nodes.
Yeah. Okay, I think that we talk a little bit through this. We also are a bit out of time accessing network service. Okay, so as we said, the two types of clients that we have here, the kernel one and the VPP one, they have we're also demonstrating different ways of enabling NSM, enabling clients to talk to NSM. So we have the standard sidecar container type of, it's not actually a sidecar, it's an init container, which is, whoever is doing NSM already, it's essentially just you annotate your pod, and then we have admission control that injects an init container, which requests the service as per the annotation, and then you get your kernel interfaces injected, the container dies. And the other one is to have a smarter client, which is based on the SDK. This is what we do with the VPP client. So I don't know what else we have. Okay, so these are the Twitter accounts for both projects. Yeah, we have a couple of workgroup calls, Slack, so you can connect to this with us. Maybe more important is to show the CNF Testbed ones. There's a weekly Zoom call. If you're interested, join. We have there's a Slack channel for people interested, and of course, send issues, PRs. Follow us on Twitter, etc. Questions, because we're out of time.
Any questions?
The gateway that you highlighted, those are like generic gateways, right? Those are not like what that gateway is?
So because with NSM we talk about layer 2 and layer 3, this essentially is a layer 3 gateway. It's a router.
Okay, just a router.
Yeah. Don't know what else we have. Thank you. Okay.
Do you have any plans to bring like actual packet gateway in the CNF testbed? So you have talked about like the CNF. So like when I say packet gateway, like an EPC gateway.
Mm-hmm.
Sure.
I
I think the main thing is, do we have a good specification for building something out, or is there something open source that we can pull in?
Various open source EPC gateway out there.
So if there's, just contributing by passing some links to some would be helpful. Some of the original stuff that this was started on, CNF Testbed, was an ONAP demo, which is like, if you're in the ONAP org on GitHub, the demo, and it has a lot of the network functions are based on VPP, but there's other ones that are not, and we pulled some of those in originally, and then we decided to go down and have it simpler and build up so that you could use these to build larger pieces.
Also, some of the future work that is planned with NSM and the CNF testbed is based on, we're targeting to have a use case which we have 4G or 5G core to be deployed there. So we are considering a couple of open source projects. At least I am considering open air interface and OMEC. I know that we have some discussions here, and we will get some packet gateways from there for sure. So. But this is more a complete story, end to end.
I work for the OMEC project.
Oh, okay. We should talk.
Yeah, definitely. We're targeting, I don't have the roadmap on here, but I think that's like January for that one. And we're trying to have that integrated NSM with potentially that one was what we were looking at.
Okay. Good. Other questions?
All right.
Okay. Thank you.
Thank you.